तो चलिए शुरू करते हैं।
Hello everyone, my name is Om and I'm your guide for the journey of Python for data science. And till now we have been continuing the lectures of week 1, week 2, week 3, and here we are there on week 4. So we are just also gonna continue the same videos, the practice videos, the test videos, the test series. In future some of the lectures, but till that we just need to complete week 4. So before starting with week 4, let's see that I just need to check whether we just got good marks in week 3 or not, because we were just making a mistake in week 1, right? Since you're just following me, I just need to check it out that you just need to score a good marks. So yeah, it's correct. Yes. Sounds good, right? It's good. Getting a good marks, yeah. So till now we are going good in all the weeks. Sorry, I can't check for week 2 because I haven't submitted week 2 yet. So sorry. Yeah. So with the same energy, let's begin with week 4. Exploring, yeah. So what does the before that, let's open the, yeah, it's already open, yeah. So what does the first question says is, which of the following are regression problem? Assume the appropriate data is given. Okay, they are telling us to assume that this data is correct. Let's assume. Now, predicting the house prices, predicting whether it will rain or not on a given day, predicting the maximum temperature of a given day, predicting the sales for the ice cream. Cool. What we just need to do is, which of the following are a regression problem? We just need to find it out which amongst them are the regression problem. Sorry, it's been yeah. Which among of those 4 options is a regression problem? Basically, first let's understand what's a regression problem. In machine learning, a regression problem is when you predict a continuous value number that can take any values in a range. Okay, basically, a regression problem is the continuous series of a number. It can be anything. For an example, let me give you an example of stock price. Some of you might be investing in stock markets too, and analyzing the trends according to the numbers going up and down from 9 to 3 o'clock, right? So the market, the numbers fluctuating in the markets, the graph been forming is the regression, right? And opposite of this is classification. uh, Classification where you predict categories like yes, no. Means basically it depends on the it's categories. Classification is just justifying 2 categories, 3 categories, or a number of categories like yes, no. The categories in general like male, female. Similarly, now let's look up on our options. First option is predicting the house price. House price can be fluctuating from some numbers starting from 5 lakh, 6 lakh, 7 lakh, 8 lakh, 9 lakh till 25. It depends on the house, the area, right? So it's not a categories like uh, building A is having this category of price, building B is having this categories of price. Yeah, it depends until and unless that particular building is a building is having 2 BHKs, and the building B is having 4 BHKs. That's a different thing, that the price range has been fluctuating from here to there, but it has not been classified into categories that building A is a different classification and building B is a different classification. All the prices from in the properties and the house prices are in a regression manner. It's a growing or it's been decreasing off, so it's considered in a regression problem. Yeah, so we can just click it off this one. We can consider it as an answer for regression problem. Now Predicting whether it will rain or not on a given day. Basically, it's not a regression problem, it's a classification problem. It's just asking us that will it rain or it will not. Means it's sorry, it's just asking that say yes or no. Today it will rain or it will not rain. I need to go to school. If you are going to school, you're just asking to your mom, Mom, is it raining outside? I just need not to go to school because if it's raining, I'll not go to school. Similarly, they are just asking us that it's a raining or it's not. So it's classification problem for sure. It's just been classified into yes and no. So we'll not consider this option as a regression problem. Um, Option three: predicting the maximum temperature on a given day. Um yes, it can be considered in a regression problem because it's a numbers been increased or decreased. If we have been playing with numbers in a frequency, in a range and a flow, then it is been considered as a regression problem. So this will also be considered in a regression problem. Predicting the sales of the ice cream. Uh, yeah, this has also been considered in a regression problem because it doesn't depend on the categories that this ice cream has been selling. It's a different lookout of the companies. The classification even the ice creams can be considered as a classification problem, but not in this case right now because we are just counting the sales all over the sales of the ice cream. We are just not having in some categories like chocolate ice cream, vanilla ice cream, butterscotch ice cream. So if the companies are just identifying the sales according to the categories, they can consider the ice cream sales in categories. But fortunately, we are just not having any other options of the flavors in the ice cream. So we will consider this particular thing as a regression problem because it's all over the count. We are just having the total price of that particular ice cream sale in particular month or a particular year, and we're just marking it up for next year's and furthermore years. Yeah, so we'll consider this as a regression problem. Proceeding further with question number 2, what does it says is which of the following are multi-class classification problem. Okay, okay. So, basically, first of all, let me introduce a multi-class classification. It's not much different thing. It's a similar thing like classification. Classification has been done in two categories: yes, no, spam, email spam classification. Yeah, it's a spam email or it's not a spam email. Likewise, and similarly. It's raining, yes, it's not raining, no, the same thing. And what does a multi-class classification problem says right now is, sorry, multi-class classification means classifying into more than one type of categories, right? You can see over here, there is two categories. One is spam and another one is not spam. So it's just binary classification which has been considered among two of them. Either it's spam or either it's not a spam. So we cannot classify this as multi-class classification because there should be more than two categories for considering as the question in a multi-class classification problem. So we will consider this is a binary classification. This is not a multi-class classification. What does an option 2 says is classifying a person's blood group type as A, B, AB or O. Yeah, this can be considered as multi-class classification because we are having four categories. They are classifying a person's blood group into four categories. Yeah, predicting the price of a second-hand car. No, it cannot be considered as a multi-class classification because it's a regression problem, right? Let me see. Yeah, not a classification problem. It's a regression problem. They are just saying predict the price. It's similar to house price, right? Predicting the house price. So predicting the price of a second-hand car is a regression problem, not a classification problem. Proceeding further with option 4 is classifying a movie genre into drama, comedy, action, or thriller. Yeah, this can be considered as a classification, multi-class classification problem, because we are having four of the options. It's not compulsory that always we will have four options. Okay, never. We may have more than two uh, categories. If we are having more than two categories, then it's multi-class classification. Else, if we are not having more than two categories, it's only binary classification. Cool. Let's proceed further with next question. If a linear regression model achieves zero training error, can we say that all the data points lie on the straight line in the feature space? What do you say? First of all, have you understood the question? What does the question says us? Boys and girls, we just need to brush it up the concept of linear regression. A linear regression model tries to fit a straight line in a hyperplane in a high dimensional through the data point so that the difference between the actual and the predicted value is minimized. The error we talk about is usually training error, how far our prediction are from the actual training data point. Linear regression is similar to a normal regression, likewise, in a 2D plane, right? It has been done in a 2D, it's not been done in 3D. What does a zero training error means? The line passes exactly through all the training points. Means, let's suppose we are having 10 points been plotted in a graph, and a line, a linear regression line, which has been, let's suppose this is a graph and this is a line. Okay, if I'm sorry, just a second. Yeah, just a second. Yeah, let's suppose this is a graph in which has been plotted over here, and this are the sequence of this is the sequence of point which has been going, and this is a linear regression line. If this line is passing through all of this point, then it is considered as zero training error. And let's suppose if this line is passing like this, then it's not considered as zero training error. Understood? And if it is passing through all of the points, then and then only it has been considered as zero training error. Whiteboard, let me show you if possible. Yeah, so this is a graph. I'm sorry. Yeah, this is a graph. I'm not a pro in drawing, so yeah, we are having some points being plotted like uh, this, 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 this. If a line, if let's suppose that this particular thing is like this, let's erase this, eraser. What is eraser? Yeah, eraser. Let's suppose we are plotting this. Oh, sorry, my bad. Let's suppose we are plotting this thing. Okay, this is our graph which has been plotted, right? And if we select, yeah, it's green. If we this is a normal graph which has been plotted. If we have been plotting a linear regression which is going like this or like this, or where do we change the color over here? Yeah, yeah. So, if the line is passing like this, sorry, like this, or like this also, then also this has not been considered. This is considered as a linear regression, normal linear regression. But if the line is passing like this, means following all of the points and going, don't consider this as a line is not touching, but yeah, the ignore this particular empty box blur. But oh, sorry, my bad. What am I doing? If there is the blue part of thing, this is called zero. Just a second. Yeah. Okay. Blue part is the zero training error. And the one which is in green is a normal linear. Understood? The one which is in green, it's normal linear regression, and the one which is in uh, blue, it's considered as a zero training error. Since it's covering all the points, since it's covering all the points which has been plotted in the line, it's considered as a normal, it's considered as a zero training error. Okay, now this part is, the green part is considered as, as normal linear regression. So, uh, yes, so our answer would be yes, right? So read the information given below and answer the question 4 and 6. Okay. Data description: an autonomous service chain is launching a new brand service station this weekend. They offer the service on wide varieties of cars. The current capacity of the station is to check 315 cars thoroughly per day as an inaugural offer. They claim to freely check all the cars that arrives on their launch day and report whether they need serving or they need service or not. Unexpected, they got 450 cars. The servicemen will not work longer than the working hours, but the data analysts have to. Fortunately, he has to work. He can't do anything. He's not a worker. He's an analyst over there. Can you save the day for the new service station? How can a data analyst save the day of them, day for them? He has been given a dataset service train.csv that contains some attributes of the cars that can be easily measured, and a conclusion that if a service is needed or not. Now, for the cars, they cannot check in detail. They measure the attributes and store them in service test. CSV. Cool, we're having two of the data set. We just need to do some games around this. Okay, we just need to play around these two data sets. Let's do. So, what we have been told is which of the following machine learning technique would not be appropriate to solve the problem given in the problem statement 4. Okay, let's understand the question first. The service station needs to figure out whether a car requirement service or not. Means basically what does the question says is we just need to figure out whether a car requires a service or it's not been required any service. Okay, Yes, needed a service. No, doesn't need service. This is a categorical data, specifically binary classification, because there is only two possible outcomes. See, I just told you in a previous question that binary classification is considering only two categories: yes, no. Means it's not compulsory that it will consider only yes and no. It may consider any other thing, that male, female, spam, not spam, and further more things. But I'm just giving an example that it will consider only two things, only two possibilities, right? Now, choosing of the right machine learning technique. KNN can classify the data points into categories. Yes. Random forest can do classification. Logistic regression, despite the name, it's used for classification. Okay, doesn't. Sorry. I'm sorry. Don't go on the name that logistic regression may be a regression problem type of things. No, it's a classification one. So this three of them are been considered as classification categories, types. So this is a regression problem. We cannot classify this particular problem into a linear regression part of thing, because we just need not to find the sales and type of things. Okay, we just need to classify as it may need service, it may require service, or it may not require servicing the car. So yeah, this all three of them will give an answer that yeah, it's requiring a service, or it's not been requiring any kind of services. And this one will not. This one will give us a friendly graph that yeah, the sales is going likewise. So considering this is an answer, prepare the data of the following steps given below and answer the question 5 and 6. Okay, cool. Encoded categories values, variable services yes as 1 and no as 0 for both the train and test data sets. Split the data of independent features and the independent features of both the train and test data sets. Set random state for the instance of the logistic regression class as 0. Cool. समझा कुछ नहीं, फिर भी आंसर करेंगे ट्राई. चलो. After applying logistic regression, what are the correct observation for the resultant confusion matrix? So I'd like to share one particular thing for this. Let me see, just a second, boys and girls too. Yeah, after applying oil, okay, this one. Recall what confusion metric means. It just means a table that checks how well a classification model like logistic regression performs. It's nothing much more than true positive, false negative, false positive, true negative. Means true positive, true negative, false positive, false negative. It's similar kind of like, okay. We just need to find this. Okay, we just need to find answers among this. After applying the logistic regression, what are the correct observation from the resultant confusion matrix? Cool. Let's first take an example of, yeah, I hope it's visible. Yeah, example of cars. Sorry, what's happening here? Yeah, imagine we have 128 cars. Okay, some need servicing, yes, some doesn't need servicing, no, right? The model predicts for each car whether it needs service or not. Okay, this will correctly say 29 needs services. Means, okay, means we just need to analyze the particular thing that which needs services and which need not need service according to this particular data that which we have been given in the this data, service train and service test. Okay, according to this both the tables, we can figure it out that what thing is going on. Okay, yeah, so sorry, sorry for this mic, I'm really sorry. uh, you can just try it out for confusion matrix problem and supporting part of the same. After checking, the model correctly says that 29 cars need services. Will be 20. Oh, sorry, TP will be 29. The model correctly says 94 cars don't need services. Okay, among 128 cars, 29 cars need services. So truly positive is 29 cars. Among the 128 cars, 94 car don't need services, so truly negative will be 94, and false positive means mistake by the model. The model makes 5 mistake by saying car needs service when it doesn't. Means our model has misunderstood some data and had made 5 mistakes, considering that a car needs but fortunately that particular 5 cars need to take any kind of service. Okay, so our false positive will be 5. So according to this particular thing, what's the answers? Truly positive, 29, 29. So this is first answer. Truly negative 94 and false positive 5. Truly negative 94. Possible. Yeah, we are having just two answers. So the logistic regression model builds the input and output variable is checked for prediction accuracy of the test data. What is the accuracy range in percent? Okay, this is a quite interesting question. I'll let you know. Just a second, boys and girls. Understanding what's happening. We have training data and we have test data. Cool. Cars with features like quality, mileage, engine sound, and label needs services. Yes, no. Basically, cars with the features having quality, mileage, engine sound, and a column which consists of service yes or no. These are the training data, and the testing data are the predicted outputs. Okay, can cars we want to predict for. Cool. We use logistic regression to build a model that predicts yes no for the test set. Okay, we use logistic regression. Cool. Accuracy and classification. Okay, accuracy is what? Number of correct option. I'll write the. Oh, sorry. Yeah. What is accuracy formula, boys and girls? Sorry, no. Yeah. Sorry. Number of correct predictions by total number of predictions and 200. For example, if a model predicts correctly that 85 out of 100 cars, okay, for example, if a model predicts 85 out of 100 cars needs correctly that 85 out of correct. Sorry. If a model predicts correctly for 85 out of 100 cars, so the accuracy will be 85%. Similarly, realistic accuracy range. What has been realistic accuracy range? Let me show you the thing. Just a second. Actually, I am referring a document which has been created by me only. So don't worry, I'll just provide that particular document in a description also. Relax for singles, you'll get that particular IP1 file also. Okay. Logistic regression is good, but it's not magic. Real world binary classification problem often don't hit 95% unless its data is very easy. Yeah, uh, we cannot consider our accuracy. We cannot consider our accuracy 95%. Of course, 95% accuracy is the best, but not considered in real life because either if you are getting 95% accuracy, then either the data might containing some outliers, or the data might not be proper, or else the data is so simple that everything has been considered in training part. And if uh, given the data set is real world car with various noise attributes, a reasonable accuracy would often fail. Okay, okay. If a data set is real, having missing values, having noisy data, having few outliers, not much, and a mixed kind of data, so the data might fall around 80 to 89% of accuracy, which is a quite good accuracy, and which is quite good accuracy, and can consider it off. So we are having the options of 60 to 79, which is very poor rate. We shouldn't consider the 60 to 79% accuracy, and 90 to 95 is too much. Possibly, but often means either very easy data is over. Yeah, I told that either the data is very easy, either the data is fully overfitting. Okay, it's mostly the most of the part of the data has been overfitting. Either the data is fully correct, मतलब basically fully easy, and 30 to 59 is again a big no. It's a bad model. If your data is giving accuracy of 30 to 59, means you are making a big mistake somewhere and predicting the accuracy, creating a model, writing up the code for the model. You just need to check it out over there. So we can consider 80 to 89 over here as our answer because it's a good range to get the accuracy. If we are getting the accuracy between this range, then our model is working good, and you should proceed further with the next thing. Okay, now how are categorical variables uh, pre-proceed before model building? Proposed before model building. So this is a classification thing. Let me drink water, please. Sorry. Yeah. Where were we? Yeah. We need to why we need processing for categorical variables. Why? Pre-processing. Okay. When we build machine learning models like logistic regression, decision tree, random forest, the computers work with numbers, not text. Okay, this is encoding techniques, right? Uh, you have heard in the classes also that a computer cannot take variable things like uh, computer cannot understand what is ohm, what is NPTEL, what is Python, what is data science. A computer cannot understand this particular variable, but if you are giving this values as numbers, the computer will definitely understand. Computer only understand the language of zeros and ones. So how will we convert our data into zeros and one? It's very simple. It's the encoding techniques. Okay, I'll tell you each and everything one by one. So before that, we'll start with an example. So let's suppose we are having three categories as red, blue, and green. Now we cannot say machiners say hey this is red, this is green, this is blue, right? Machine will say, hey damn, I can't understand what you are telling me. What's red? What's blue? What's green? I can recognize what's blue, what's green. I don't know what you are telling. What rubbish you are telling? No. You can see machine as encoded values as, let's suppose you are having three categories again. Let's open up a whiteboard. Just a second, please. Sorry, but the setup is messed up over today. Yeah. So green, blue, red. So if we are having this categories, what we can say is to the computer that consider for let's suppose you want to take a blue color, right? Why it's not copying? Yeah. Let's suppose we want to make a green color. How we will make? We will probably say this as 0. No, 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 not like that. I'll say you. Wait a second. Considering this as value 0, I'll show you just a second, please. 0, not this. Yeah. So if we want to tell computer that we need green color, how we will say is 0, 0, 1. This is green color. And let's suppose we want to say blue color. How will say a blue color? It's easy. We will just say 0, 1, 0. If we want to say red color, then how we will say? We will say 1, 0, 0. Now there is a trick in this particular thing. I'll let you know. Just a second, please. Yeah. While working for a machine learning program, we always need not to consider one first row, because it's a good good thing that we can ignore this line. Always while working in machine learning models, we ignore the first thing. The first row is always been ignored in machine learning model while encoding, because it consists a lot much of memory. Here the data is only 3, but fortunately, if you think, if we are having millions of data, then how much rows it will create? 1 2 3 4 till many rows it will be creating, right? So it's a it's big consumption of space. So we'll ignore this particular first line, because ignoring that line also gives us the same result. If we are considering 0 1 0 as blue, 1 0 0 as red, then for sure the last option, which is 0 0 1, is green. Then why should we consider this whole of the data for this particular line? For this particular line, if we are not considering, if you want to consider this both options, we are having the correct encoding techniques for this both options, right? Then why should we consider this line? it's it's more or just taking up the space in a PC, not much more than that. Okay, so yeah, this is encoding. My drawing is not good, but yeah, this is a decent table. Yeah, yeah, this is encoding part. Okay, now let's move to the question. What does we need to do? The correct methodology, dummy variable, one hot encoding. The one thing which we have done over here, this is called, I'll give you a title over here. This particular thing is called one hot encoding. No boys and girls, this is called one hot encoding. Pronounce it correctly, okay? The correct method, dummy variable. Okay. We create dummy variable for each categories. Of course, this is the first thing that I told over here. The thing that we are just gonna remove is dummy variable. Uh, I just gave an example of red, blue, green. You know how we can do the encoding in this particular thing by using get dummies. The small code to get the dummy variable is uh, writing code that get dummies. I'll just show you one thing if possible. Import pandas as pd. Now df equals to pd dot data frame. Okay, okay. No, we not need this much thing. Okay. We having this much of data. Cool. Right. Df underscore encode date equals to this. Yeah. So, what do you think? What answer we might be getting? See, it's false, false, true. Basically, the false is 0 and true is 1. So, it's the same thing that we did over here. 0 0 1. 0 0 1 is red. This particular thing is here. This particular thing is here. This will change, but then all the things are true. Yeah, here's just, oh sorry, here's just interchange this value, and all the things on all the other things are the same. Okay, now where my errors? Why this is not working? Anyways, mouse is not working, sorry. Anyways, answer is dummy variable because standardization use numeric data to bring values to the same scale. It's standardization is the one which uses numerical data to bring their values at the same state. Okay, if you are working on 2 to 3 data and you just need to scale it up to the same values and then continue further with your calculation, then standardization will help you a lot. And if you're not considering that particular thing, if you are going for option 3, which is correlation, which shows the relationship between variables. Correlation will always show the relationship between variables, and dummy variable is a thing which specifies the categories into numerical variables. Okay, similarly we did over here, like get dummies is a function which has been used in pandas, okay, to encode the categories. So this is the one which has been used to encode the categories. Okay, a regression model with the function y equals to et plus 4.5x was built to understand the impact of the temperature x on ice cream sales. Why the temperature this month is 10 degrees Celsius more than previous month? What is the predicted difference in the ice cream? Okay, we just need to find the predictive. Okay, what we have been told is every year the degree is been increased by 10. Okay, so initially first year we are having the degrees as 80 plus 4.5x is 80 plus 4.5 into 10 is 45 plus 80. What is 45 plus 80 is 125. So similarly we just need to calculate for more 2 years, and we need to find the difference of that 2 years. So 80 plus 4.5 into 20, because initially first year it was 10, then second year the degree will increase to 20, so x, the value of x will be 20. So 80 plus 4.5 into 20, that gives 170. Okay, now increasing the degree by 10 again, the degree will be 30. So 80 plus 4.5 into 30 will give us the answer is 215. Okay, now 215 minus previous 170 will give 45. You can calculate, and the calculation has been provided in the description IPYN file also. You can just go throughout that particular IPYN file in detail. IPYN file in detail. X and y are two variables that have a strong interrelationship. Which of the following statement are incorrect? Cool. We just need to find interrelationship between them. Okay. There cannot be a negative relationship between two variables. Why so? A strong linear relationship can be positive or negative. It doesn't matter. It can be positive, it can be negative. Let's give an example. If the temperature increases, hot coffee sales decrease. Negative correlation. Yes. So the first option is incorrect. The relationship is purely casual. Wrong. Correlation doesn't prove question. Two things can move together without causing the other. Example, ice cream sales increases as drawing incidence increases. Okay, then what does a drawing incidence is? Let me tell you. It's just a breathing problem which has been occurred in summer due to hot temperature. So as the ice cream sale increases, drawing temperature also increases because it's summer. So this can correlate. So option 2 is also incorrect. The two variables are purely casual. No, they are not. One variable may or may not cause a change in other variable. Of course, the changing in one variable obviously will not affect. Obviously will every time not affect the second variable. It may affect sometime, but every time it will not affect the second variable. So we can consider this option. The variable can be positive or negatively correlated with each other. Of course, it may be positively or negatively correlated. No, it's not compulsory that it should be positive or it should be negative. It may be any of them. Finally, proceeding further with the last question, the Global Happiness Index report contains the happiness score data with multiple features, namely the economic, family, health, and freedom, that could affect the large values. Prepare the data by the following step given below and answer the question 10. Okay, cool. We just need to download this thing. Download. Yeah, download it. Downloads. Okay. Yeah. So we are having this particular data. What we just need to do is we just need to do some calculation of this. We just need to do multiple linear regression model. Okay. Multiple linear regression model is built on the global happiness index. Okay. Winners need to find root mean square values. So let's write the code for the same. Ready? Let's go. Let's give an heading. Question. Oh, my bad. Sorry. 10. Import pandas as pd d equals to pd dot read underscore csv. No. Yeah. We'll copy the path. We'll give the path here over here. But what's happening today? Yeah, we got the data. Now let's split the data. The very first step is splitting the data. Now x equals to df. इसमें हम लोग को क्या चाहिए? Economy. Let's write this spelling here. We are just very lazy peoples. Economy. Fam and health. Sorry. Fam and health and freedom. We are just doing a linear regression model and finding the accuracy. What's the accuracy coming out over there? Y is but this is not happiness score, this is H score. Yeah. Now, so what we did here is we are just getting X is what influence happiness and Y is the happiness score itself. Now we are just splitting our data into train and test. Train, test and split. X under from skill and model selection, train, discussion, discuss, split. Okay, here is 23. Yeah, we got it. We are just splitting our data into a random train and test set. Okay, it's been done. After this, training multiple linear models. Okay, now we are just training. multiple linear regressions. So here is a code for linear regression. Checking out the linear regression models one. Okay, now this, not this. From SK learn dot linear model for linear regression. Model linear regression. Yes. Not this. Training and testing. Yeah, this much. Yeah, here we have been checked for linear regression model, and now we are proceeding further with the step 4, which is predicting root mean square value. Step 4 is predict root mean square error and prediction and root mean square error. Okay, so this has been done as import numpy as sorry, my bad. From a scale learn processing root mean squared error. Okay, by predicting root mean square is np dot square root of mean squared error y test y prediction. Cool, going good. We are just printing root mean square error. This will give 0.47. Okay, so according to our answer has been over here, just a second, I'll show you. Yeah, we are getting the answer as 0.47, 0.472009 something, but we are not getting any of such kind of options over here in our options. So what we should do right now, we should select the nearest option to 0.47, which is 0.05. Okay, according to you, you should do whatever you think. It doesn't mean that you should consider only the answer that I am showing over here, but if you believe me that these answers are correct, you may continue further with the submit button. But if you don't, that you think that, oh no, these answers are wrong, you may think upon yourself also, and you just need to do a bit of research and can proceed further with your answers also. So yeah, here we end up our session. If you are feeling any of the thing that you are stuck at somewhere, then you can for sure ask in the WhatsApp group, or else even in a comment section is open. And yeah, let's finish up the lecture right now. Thanks for watching.